Today we're going to talk about the arc length and area of a sector. So the arc length, if you see our original circle here, up until now we've measured the arc length, the degree measure, because it's the same degree measure as the central angle. What we want to do though is actually find the physical length of the arc. So our units instead of degrees would be centimeters, inches, whatever the dimension of the radius is in. We have some notation, a lowercase s, that's a lowercase s, that denotes the arc length, not the degree measure. And that's what we're going to find today. Now to find the arc length, we use a scale factor. We've done that many times when we talk about similar circles and similar items. We always use a scale factor. So that's what we can do to figure out the length of this arc in comparison to the length all the way around a circle. We're going to use our degree measure, our central angle, to set up the scale factor, because the central angle can be a ratio in a ratio with the angle measure all the way around the circle, and we can compare that to the length, the arc, to the distance all the way around the circle. So that's what we're going to do. Our scale factor, in this case, our scale factor, if theta is the central angle in degrees, our scale factor is going to be theta over 360 degrees. So we can find the arc length by taking that scale factor, theta over 360, and multiplying the entire distance around the circle. We know the entire distance around the circle, that's the circumference. And the formula for circumference is 2 times pi times r. So using this formula, we can find the length of any arc contained in that circle if we're given the central angle and the radius. So let's make a calculation here. We have a circle, and it has a radius of 10 centimeters. And we have a arc length, or we're going to say an arc length of 60 degrees. That's our angle measure. We know this arc length is equal to the central angle subtended by that arc. I can draw that in here as best as I can. So we can set up that ratio. The 60 degrees is going to be part of our scale factor. The arc length, lowercase s, is going to be 60 over 360. And to that we multiply the circumference, 2 times pi times 10. Reducing things down, 60 over 360 is 1/6. That's our scale factor. It's 1/6 of the distance all the way around. 2 times 10 is 20 times pi. If we left our answers in terms of pi and reduced down, we'd have 20 pi over 6. So in the end, in terms of pi, we have 10 pi over 3 centimeters of length for just the arc length as compared to the entire distance around the circle. So now we're going to use the same process, only this time we are starting with an inscribed angle, and we want to measure the length of this arc. Now we can get the degree measure of the arc because we know that an inscribed angle is going to be half the degree measure of the intercepted arc. So given that, we know that the degree measure of arc AC is equal to 2 times 60 degrees, which is 120 degrees. Let me write that a little bit better here. 120. The degree measure of the arc is equal to the central angle, so we can use that degree measure to set up our scale factor and find our arc length. So it's 120 over 360, and we multiply that by 2 times pi, and the radius is 36. So once you simplify all that down, 120 over 360 is 1/3, and then we have 36 times 2 pi. 36 is actually divisible by 3, and we end up with our arc length is 24 pi centimeters. That's our length, and we keep it in terms of pi because that's exact. We can also find the area of a sector the same way because we can scale the area of the sector by our central angle again. Now, a sector is defined as all the space that makes up in between the two radii that create the arc. So it's like a slice of pizza. And when we talk about a sector, this is the shape, the radius is on either side, and the central angle's in the middle. So we want to figure out the area of that. Again, we can use the same scale factor because, and this time we're going to apply the scale factor to the area of an entire circle. The area of a circle, we know, is pi r squared. So we can scale that answer with the central angle. So the area of a sector is just theta over 360 again, and we multiply that by pi r squared. So if we have a circle that has a radius of 10 centimeters, first of all, let's find the area of the entire circle. We're going to leave it in terms of pi again. And we know the formula for the area of an entire circle. It's pi r squared. So we only need one dimension. The area is going to be pi times 10 squared. So this area is 100 pi square centimeters. Well, given that, if we wanted to find the area of half the circle, we don't need an angle to determine our scale factor because we know our scale factor is going to be 1/2. So we want half the area. So it's going to be 1/2 times 100 pi. And that's 50 pi square centimeters. And we'll finish with one more example, and then we'll do more of the examples in class that are in your notes, plus some extras. So in this example, the area, we're given the area of sector AOB. So AOB is here, and we're given the area measurement in there. And that's 28 pi. So the area of a sector is 28 pi, and we want to find the measurement of the central angle. Now here we also have a radius of 12 centimeters. So this is one of those problems where you work backwards. We know the area of a sector, if I say area of a sector, is going to be the angle divided by 360 times pi times the radius squared. And now we just substitute in what we know. We know that the area is 28, so he'll go in here. And we have the radius is 12, so he'll go in there. And eventually we will solve for the angle. So 28 pi is equal to theta over 360 times pi times 12 squared. Okay, and now we just simplify. I have a value of pi on both sides of the equation, so those will divide away. And I have 28 is equal to theta over 360 times 144. When I solve, you can cross multiply, you can simplify that fraction. There's lots of ways you can solve this. 28 over 1 is equal to 144 over 360 times theta. So you can say 360 times 28. Oops, let me clean that up a little bit. 360 times 28 is equal to 144 times theta. And in the end, you get theta is 70 degrees. So that's an introduction to using a scale factor for finding the arc length and the area of a sector.